So finishing off 4.4 today, remember tomorrow you guys have a quiz on chapter 4, and then we'll be getting into chapter 5 as well. And we'll see chapter 5 deals mostly with the graphs of trig functions, so we'll see what those graphs look like, and then we'll do some transformations of them using the same processes and principles that we've been using for all of our transformations. But first we need to finish off this chapter and continuing looking at some more examples where we're solving trig equations. So if you've got the equation sine squared x minus 1 equals 0, you want to solve for x between 0 and 2 pi. So again, the fact that you're given the domain in radians means your answer has to be in radians. And if we can get exact answers, exact values for our answers off the unit circle, then that's what we would do. Okay, so maybe we'll start by reconstructing our unit circle. So we know here at 0, the coordinates are 1, 0. At 90, there's 0, 1. At 180, it's negative 1, 0. And at 270, it's 0, negative 1. And then we have our 3 stops in the unit circle between 0 and 90. One being at pi on 6, which is 30 degrees. Another being pi on 3, which is 60 degrees. And then we'll also have one halfway in between 0 and 90, which is 45 degrees, or pi on 4 radians. So again, at pi on 6, or 30 degrees, the coordinates there were root 3 over 2 comma 1/2. Up at pi on 3 radians, or 60 degrees, the coordinates are 1/2 comma root 3 over 2. And remember, you can use the hand trick to get those. At pi on 4 radians, or 45 degrees, they're both root 2 over 2. And then we also had our tangent values. Again, those are found by going sine divided by cos. At 30 degrees, it was root 3 over 3. At 45 degrees, it was 1, and at 60 degrees, it was root 3. Now, you can always use your calculator to check these, to make sure you have the right values. So I am in degree mode, so if we check these in degrees, if we take the cosine of 30, which remember cosine is the x value, you'll get that decimal, which if you check, is equivalent to root 3 over 2, which is what we wrote down. Same decimal. If you take the sine of 30 degrees, you'll get 0.5, which is what we wrote down. If you take the tangent of 30 degrees, you'll get that decimal, which should be equal to root 3 over 3. That's what we wrote down, and it is. So we've just checked that our numbers we wrote down at 30 degrees are all correct. The cosine of 45 is that decimal. We wrote it down as root 2 over 2. Calculator doesn't give you the exact value, unit circle does, but it's the same value. Same thing with the sine of 45, it'll be the same decimal. And the tan of 45 is 1, so that is correct. Okay. The cosine of 60 degrees is 0.5, that's what we wrote down. We wrote down a half. The sine of 60 is 0.8660, which we've already seen is root 3 over 2. That's what we wrote down. That's equivalent. And the tangent of 60, we wrote down root 3. Calculator doesn't give us the exact value though, but when we put root 3 in, we get the same decimal. So again, those values are all correct. Okay? So, solve for x in the interval 0 to 2 pi. Again, we'll be giving our answers in radians. Also, notice that if there's any answer on the positive x-axis, you would include 0 as an answer, but not 2 pi. X is greater than or equal to 0, only less than 2 pi. Okay? So we want to solve this equation. Tyson, what do we do after you put your phone away? Okay? Or sine x would equal plus and minus 1. So sure, you need to get the trig function part by itself, and remember that sine squared x means the sine of x all squared. When we take the square root of both sides, you will get plus and minus 1. So the sine is the y value. It equals positive 1 up at pi on 2 radians and negative 1 at 3 pi on 2 radians. Those should be our answers. And we can check them. In this case, we need to be in radian mode because that's what mode our angles are in. The sine of x all squared take away 1 should equal 0. So we need to open a bracket. We'll take the sine of pi on 2, close the bracket on the pi on 2, close the bracket on the sine of pi on 2 so we can square it, and then minus 1 should equal 0, and it does. And then checking 3 pi on 2, it also works. So you can always check your answers. You should never get any stated answer wrong. Again, it's possible you may miss some of the answers, but you should never get any stated answer wrong. Now, this also asks us to find the general solution. So if we look at this, we have an angle at pi on 2 as one of our answers and 3 pi on 2 as the other. They are exactly pi radians apart, no matter whether you go in a positive direction, which is counterclockwise, or a negative direction, which is clockwise. No matter which way you go, they are the same distance apart. They are pi radians apart. So we can state the general solutions as x equals pi on 2 plus every multiple of pi. So we'll say pi on 2 plus n pi, where n is an element of integers. We use this same notation when we did our coterminal angles. When we talked about all angles coterminal with a given angle, this is what we did. This is no different. We're just extending that now to saying these are our general solutions. And general solutions means all solutions between negative infinity and positive infinity. That's what that means. Okay? Example 2 then. Solve each equation. Give solutions as exact values where possible. Otherwise, approximate angle measures to the nearest thousandth. So this first one, again, we're in radians between 0 and 2 pi. 0 would be included, 2 pi wouldn't. And in this case, we have a sine squared theta term and a sine theta term. So I would collect them all over to one side, all the terms over to one side, make it equal to 0. Now what, Tyson? Factor it. And if you want to use that substitution method, say let x equal sine theta, that's fine, as long as you put the sine theta back in after. But the front terms multiply to get 2 sine squared theta, so it's 2 sine theta and sine theta. When you multiply out the binomials, you have to get a positive 1 sine theta in the middle. The last term is multiplied to get negative 1, which means you need a positive 1 with the sine theta. The negative 1 will go with the 2 sine theta. And so our solutions come when each factor equals 0. So for that first one, it'll be where the sine of theta equals positive a half. Let the second factor equals 0. And this will be where the sine of theta equals negative 1. Both of these values are on the unit circle. Remember, the sine of theta is the y value. It equals positive a half here. at pi on 6 radians. But that's the answer in the first quadrant. There will also be an answer in the second quadrant, because our CAST rule tells us that the sign is positive in quadrant number 2. So we're going to look for the rotation angle in the second quadrant that has the same reference angle as the first quadrant, which is pi on 6. And so that would be just pi on 6, or 30 degrees short of 180 or pi radians. So if you're at pi radians, which is 6 pi on 6, and you back up pi on 6, that'll take you to 5 pi on 6. So there's our second answer for the first factor, where the sine of theta equals a half. The sine of theta equals -1 only in one spot, which is 3 pi on 2. Remember, the y value is the sine of that angle. Okay, so now we're going to check these on the calculator. So I've got two sides to this equation, so I'll put both of them in, and I should get the same number. First, checking for pi on 6. So I have to have 2, open a bracket, because I have to square the sine of pi on 6. Close the bracket on the pi on 6, close the bracket of the sine of pi on 6, so we can square it. Gives us that value. And I should get the same value on the right side of the equation when theta is pi on 6. So it's 1 minus the sine of pi on 6. Same value. Just so happens that in this case, when you check them, it's the same answer as when we got the sine theta by itself below. That is a coincidence. That's not always going to happen. Okay, now I'm checking for 5 pi on 6. So I need to put a 5 in front of the pi. Whoops. That should have been 2. I'm going to insert the 5 there. So it also equals 0.5. And 1 minus the sine of 5 pi on 6 should equal 0.5, and it does. And now we're checking for 3 pi on 2. In this case, you get positive 2 on the left side of the equation. So we should get positive 2 to the right side, and we do. So all of our answers work. They all work. Yeah. I subtracted 1 from both sides. There's your -1 right there. No, it's sine theta plus 1. When you multiply these out, the outer products will be positive 2 sine theta, the inner products -1 sine theta. That'll give you your plus sine theta, middle term. Okay? Look at question B. Again, our answers have to be in radians, but also notice that now we're only going to give answers in the first two quadrants, because the domain is between 0 and pi. 0 would be included, pi wouldn't. But we'll have to factor this again, which means we're going to make it equal to 0. Subtract the 3 from both sides. So when we factor this, our front terms would multiply to get 2 cos squared x. The last terms have to multiply to get -3, and when we multiply out the binomials, we have to get a positive 5 cos x in the middle, which means you'll need a +3 there with the cos x, the -1 with the 2 cos x. The front terms will multiply together to get 2 cos squared x. The last terms will multiply together to get the -3. And when you do the outer and inner products, the outer products will be 6 cos x, the inner -1 cos x. it will become 5 cosine x. So again, our solutions will come when each factor equals 0. And this will be where the cosine of x equals a half. Our second factor, cosine of x plus 3 must equal 0. So the cosine of x equals negative 3. So where on the unit circle first does the cosine equal a half? Cosine is the x value, and it equals a half up here at pi on 3 radians. So pi on 3 will be one answer. Now normally there's a second place on the circle where the cosine equals positive a half, but that second place is in the fourth quadrant, which we can't use here because we are told that our domain is that x can only be greater than or equal to 0, less than pi. The other place where the cosine is positive a half would be in the fourth quadrant, which is between 3 pi on 2 and 2 pi. It's outside of our domain. If you try and find out the reference angle where the cosine of x equals 3, you'll get an error. We talked about this last week. Remember, the graph of sine and cos only goes up to positive 1 and down to negative 1. It'll never get up to 3 or down to negative 3. Remember, normally the negative sign would just tell us what quadrants we're in. To find our reference angle, we go second function cosine of 3, which we would have to, you don't have to do anything. It doesn't exist. Don't have to change the mode. Whether in degrees or radians, it won't matter. Okay? So, and that is why, because we looked at the graphs last week. The graph of sine and cos only go up to 1 and down to negative 1. It'll never reach a value of positive or negative 3. So to check this, again, we'll use our calculator. The left side will be 2, open a bracket, because we have to square the cosine of pi on 3. And then we'll add 5 times the cosine of pi on 3. So that'll be the left side, and we should get an answer of positive 3, which matches the right side. So we know that our answer is correct. You should never get one of your stated answers wrong, because you can always check them. Only a couple things that could happen is maybe you've missed some of the answers, or maybe you've given a number that's outside the stated domain. That's possible. Okay. And so these next ones, we just want to determine the general solutions. But first, we have to figure out what the answers are between 0 and 2 pi. And then we can go from there to the general solutions. So this first one, there is a term that has a tan squared x as well as a second term with tan x. We would have to factor this. There is a common factor of tan x that we would take out. So our solutions will come when each factor equals 0. Let's go back and grab that unit circle here. So we didn't write on here. There we go, that's better. The values of the tangent at the stops on the axes. But remember, tangent is sine over cos. And so at 0 or 2 pi, it'll be 0 over 1, which is 0. But up here at pi on 2, it'll be 1 over 0, which is undefined. At pi, again, it's 0 over negative 1, which is 0. And down at 3 pi on 2, you'd be dividing by 0, so it's undefined. So the tan of x equals 0 at 0 radians and pi radians. It doesn't tell us, I don't think in this case, whether we should be in degrees or radians. So we will just go in radians. So again, the tan is 0 at 0 radians and at pi radians. And once again, whether you go clockwise or counterclockwise, these two angles are the same distance apart. So we can write one general statement for that factor. And that would be that x would equal, and we can just say n pi. You could say 0 plus n pi. You could say pi plus n pi. It doesn't matter. But just saying n pi is good enough. And the second set of solutions will come where the tan of x equals negative 1. Okay? So the tan is negative in the second quadrant and the fourth quadrant. And they will both have reference angle of 45 degrees or pi on 4 radians. So again, they will be the same distance apart, whether you go clockwise or counterclockwise. So we can write one statement for both of these. The angle in the second quadrant, that'll have a reference angle of pi on 4 because that's where the tan is 1. Remember, the negative part tells you which quadrants you're in. That's why we're in quadrants 2 and 4. But the reference angle will be the same, pi on 4. So if you're at pi, which is 4 pi on 4, and you subtract the pi on 4, that'll take you to 3 pi on 4. And again, the next angle in the fourth quadrant would also be pi radians apart. So we can just write one statement for this factor, but we can't forget to say that n is an element of integers at the end. So there's our solutions, general solutions for that one. Question B. Where is cos squared x plus 2 cosecant squared x, plus 2 cosecant x minus 8 equals 0. So because we've got a trinomial here, we have a cosecant squared term and a cosecant term we need to factor. So the front terms multiply together to get our cosec squared x. Our last terms multiply to get negative 8. So the last numbers have to be factors of negative 8. And when you FOIL out, you got to get a positive 2 cosecant x, which means we need a plus 4 and a minus 2. The last terms do multiply together to get negative 8. The inner products is positive 4 cosecant x. The outers is negative 2 cosecant x. So they would simplify to give us our positive 2 cosec x in the middle. So again, our solutions will come where each factor equals 0. And so from the first one, it'll be where the cosecant of x equals negative 4, which will be where the sine of x equals negative 1/4. The second factor, when you make it equal to 0, it'll be where the cosecant of x equals 2, or the sine of x equals 1/2. And you should recognize that nowhere on the unit circle does the sine of x equal 1/4. So for this part, we will have to use reference angles on our calculator to get our answers. The cast rule again tells us which quadrants we're in. The two quadrants where sine is negative is the third or the fourth quadrant. At this point, the negative sign has done its job. To find our reference angle, we'll have to go second function sine of positive 1/4 or positive 0.25. This gives us our reference angle, which to the nearest thousandth would be 0.253. That is our reference angle. And so our rotation angles then, the first one would be pi past, or pi plus that 0.253. So if I add pi to this, it's 3.394. And in the fourth quadrant, it'll be 0.253 short of 2 pi. So if I go 2 pi minus, and I'm going to use a few more decimals, 0.25268 is what I see above there. So I used a few more decimals just to make sure that when I round to the nearest thousandth, I get the correct number, and that'll be 6.031. Now, we want to state our general solutions though, okay? And in this case, whether you go clockwise or counterclockwise from one terminal arm to the next, the distance is not the same. Okay? If you go from the answer in the third quadrant and you go clockwise, it's much further than if you go counterclockwise, much further. So because of that, we have to state two statements for these general solutions. The first being 3.394 plus 2 pi n. The second being 6.031 plus 2 pi n. And we can just write n as an element of integers when we're done all of them. So now let's look and see where the sine of x equals positive 1/2. And that is on our unit circle here at pi on 6. The other place where that would happen would be 5 pi on 6. That'll be in the second quadrant. And again, those two angles are not the same distance apart, whether you go clockwise or counterclockwise. So we're going to have to write a statement for each. So the first being pi on 6 plus 2 pi n, as well as 5 pi on 6 plus 2 pi n. And now we can say that n is an element of integers. There's our two spots. Right, so if I just use the same xy axis that I had here from before, the first one is at pi on 6, that's a reference angle of pi on 6, and then the second one in the second quadrant with a reference angle of pi on 6. That's where the 5 pi on 6 came from. And you have to write both of them plus 2 pi n because you're not traveling the same distance whether you go clockwise or counterclockwise from one to the other. Normally that only works with tangent, normally. Or in some cases when you're on the axes, at 0, at 90, at 180, or 360. Okay? All right. On the next page. Oops. Sorry, got some more to do. Getting ahead of myself. So again, you want to solve each in the specified domain. So now it's not asking for general solutions anymore. But you need to pay attention to the domain. Not only does it tell you whether you're in radians or degrees, but also tells you which quadrants you're looking at. And so for this next one, you're between negative 2 pi and positive 2 pi. And they both could be included. So that tells us we're in radians. So for question A, there's no squareds here, so we can just get cosine theta by itself. So if I start by writing out the original equation again, if you subtract cos theta from both sides, it'll give us 2 cos theta on the left. Adding 1 to both sides gives us 2 on the right. And then dividing by 2, we'll get where the cosine of theta equals 1. And so again, if we look on our unit circle here, cosine, which is the x value, is positive 1 right here. So we would have 3 answers for that. That would be negative 2 pi, 0, and positive 2 pi. You can write them in any order you want. Doesn't matter. And remember, once again, you can use your calculator. I'm in radian mode to check. So the left side is 3 times the cosine. So let's start with negative 2 pi. And then minus 1. So that gives us a value of positive 2. We should get the same thing on the right side by taking the cosine of negative 2 pi and adding 1. And we do. So that one checks. Now let's check positive 2 pi. We also get 2. That was for the... Let's try this again. So I need to do 3 cos. With positive 2 pi. Gives us the same value of positive 2. And now let's check 0. So we can just put 0 pi if we want. It's the same thing as 0. So that was the right side of the equation. Now we'll check the left side of the equation when we have 0 pi. And we get the same number, same answer when we check the right side of the equation. So again, all 6 of these don't have to have the same value. Only the 2 with the same angle have to have the same value. And they do. Right, so there's that one done. We've found our solutions, we've checked them. For question B, we need to be in degrees this time. But first, we need to get the secant of theta or secant of x by itself. So I would subtract 8 from both sides and then divide by 4. It'll be negative 2, which means the cosine of x would have to equal negative a half. So using the cast rule, the cosine is negative in the second and third quadrants. So this is where our terminal arms would lie. Because the cosine of x equals negative a half, the negative told us which quadrants we're in. If we look in our first quadrant where the cosine of x is positive a half, that's at 60 degrees. That is our reference angle. In this case, if we check our domain, we're between 0 and 360. So the first angle will be 60 degrees short of 180, which is 120 degrees. The second one is 60 past 180, which is 240 degrees. There's our 2 answers that we would check, but now we have to be in degrees. So again, the equation. Now we don't have a secant button on our calculator, but remember, secant is the same as 1 over cos. So 4 secant x is the same as 4 times 1 over cosine x, or 4 over cosine x. That's what 4 secant x would be equivalent to, 4 over cosine x. So that's what we'd have to use in our calculator when we're checking 120 and 240 degrees. So, in brackets, 4 divided by the cosine of 120 degrees, close the bracket on the 120, close the bracket on the 4 over cosine of 120, plus 8 should equal 0, and it does. And now we'll check 240 as well. Change the angle to 240. Works as well. Right, so they both check. Okay. Cos squared x minus 1 equals 0. Solve for x between 0 and 360 degrees. So again, we're going to be in degrees for this one. So I think we saw one like this earlier, and we did it by getting the cosine of x by itself by adding 1, taking the square root of both sides. You could also do this by factoring this as a difference of squares. You would get the same answers. This is also factored as difference of squares. The square root of cos squared x is cosine x. The square root of 1 is 1. 1's a plus, 1's a minus. Remember, when you factor difference of squares, you always end up with conjugates. So you're still going to get where the cosine of x equals positive and negative 1. Whether you add 1 to both sides, take the square root of both sides to get the cosine of x equal plus or minus 1, or use a difference of squares to factor, you'll get the same answer. Again, we'll go back to our unit circle. Thank you, sir. The cosine, which is our x value, will equal positive 1 at 0 degrees. It equals negative 1 over at 180 degrees, and back to positive 1 at 360, but we cannot include that because it says that x is greater than or equal to 0, but only less than 360 degrees. So the only answers we can use here for x would be 0 degrees and 180 degrees. That's where the x value, which is the cosine, equals positive 1 or negative 1. So we can check those answers before we state the general solutions. Again, we need to be in degrees, which I am. Open a bracket because I have to square the cosine of first 0. Actually, let's do 180 first. It'll just be easier to do the second one. So close the bracket on 180, close the bracket on the cosine of 180 before we square it, and then minus 1 does equal 0. Now checking 0 degrees by deleting the 1 and the 8 also works. And because these two angles are exactly 180 degrees apart, no matter which direction you go, for part B, when you state the general solution, we can state it as 1. We can just say that x equals 180 n degrees, where n is an element of integers. When n is 0, which is an integer, you're going to get your 0 degree answer. When n is 1, you're going to get your positive 180. When n is negative 1, you're going to get negative 180, and so on. Every multiple of 180 degrees, you will get a spot where the cosine of x all squared minus 1 does equal 0. And if you wanted to check a few of those, for example, when x equals negative 180, it works. When x equals negative 360, that's also a multiple of 180. It works. And you can check any multiple of 180 degrees. It would work. Negative 720, if you want, would work. Yes, sir. Yes, it does, because if you say real numbers, you're saying that if you let n equal 0.5 or a half, that would only give you 90 degrees. It doesn't work. When it says this, determine the general solutions where the domain is real numbers, you don't have to say the domain is real numbers. If you say general solutions, that's what it means. It means from negative infinity to positive infinity, which is where all real numbers are. Okay? What they might say is they might say determine the solutions, take out the word general for cos squared x minus 1 equals 0, where the domain is real numbers. That when it says that, then you know that means general solutions. So if they didn't say general solutions, just the solutions where domain is real numbers, that would mean that it is general solutions. It means you're going from negative infinity to positive infinity. Okay? Okay. So on the next page, this is an assignment, and there's questions on the back as well. You're going to hand these in for marks, so these will be due. So you should have those done today to hand in tomorrow, which will be good practice for your quiz. So your quiz is everything on chapter 4, though, not just this last section on solving equations. So you're going to have to go back and do some studying. Remember, we're going to be talking about, or you're going to get quizzed on, we first started talking about our unit circle and our exact values. We did rotation angles. We did coterminal angles. And then we got into solving trig equations. So everything we've done in chapter 4 will be on this quiz tomorrow. Okay, so make sure you spend some time reviewing, studying, so you're prepared for that quiz. Again, so this assignment is due for marks.